So thank you so much for joining in time. And is there anyone who is attending my session for the first time? So how many have attended all the previous 3 sessions or 2 sessions or 1 session? Go on to the chat box and just give the number 1, 2, 3. So as it has already been discussed that this is the 4th session in the same sequence. Okay, so I see 3, 3, 3. First time means 0. Okay. Second time is 2, third time. Okay, good. So if this is the first time, it should be 0. If you have attended all the 3 sessions, it is 3. If you have attended the last 2 sessions or just the last session, it is 1. So 1, 2, 3 is the count of how many sessions you have already attended for this part of the series. So apart from this part of the series, I have done other DataHour sessions also. So let's see. We have got the numbers. Okay. So, okay, that is interesting. We have a lot of new guys also. Okay. I hope everyone is well aware of what we are doing, right? I mean, the context, what all we are going to do. So everyone has, let me just quickly share my screen. And the people who have already attended my previous sessions very well know that I come without a PPT. So it's all completely hands-on and mostly it is impromptu. So there are some surprise elements also. Okay, so let me quickly share my screen and share this link from where you have already registered. The reason I'm sharing this link is the recordings for the previous 3 parts are already there. So those guys who have missed the 3 sessions, here is the link. Okay, and there is a link for the GitHub, okay, where you can download all the codes. So I'll just open this link here and show you how it looks. Okay, so this repo should be publicly accessible. So anyone can go ahead and download all the code base. So at the end of the session, I'll again update it. Okay, I'll commit the latest one. Okay. So till whatever we have discussed in the previous 3 sessions, I have organized in part 1, part 2, part 3. This is the raw data file tweets. I'll give you a quick context when I start with the Jupyter notebook part, but this is the raw data. And we wrote some cleaner functions in the very first part 1. Probably, I don't know how much I'll have to repeat, but maybe I can just show you these files and quickly we can browse. Okay, but I would not take more than 10 minutes to revise, right? Because I'm expecting that you have some fair idea. But to give a context to the to the new learners today who have joined, okay, they will find some flow with this revision, okay? And this is the updated tweets that we will be actually building our model. Okay, so this session is not more on model building. It is just to make a model quickly. No cross-validation, pipeline, hyperparameter tuning, all these are already done. Okay, why we are doing, what we are doing, how we are doing. We'll only make a bare minimum model today, which is good enough for deployment. Because the session, this part 4 is more intended for the deployment. Okay, so here we will write down API codes for deployment. Okay, so today's is a session on deployment and less on model building. Although we will build a model just to go with the entire flow. Okay, all good. So let's get started. Any questions? Any questions before I just start? Okay, so you can download this entire code base. All you have to do is just go to this. Oh, sorry, I'm already logged in, it seems. Yeah. So for others, you can go to this data tab link, and from here, download the entire zip file. So you will be able to download the entire repo in your local folder. And then you can open it. Or if you want to just view it for now, you can just anyway go through the project folder and view these files. So that is still possible. Yeah. So before I start, this is a quick disclaimer here that the codes are already shared and whatever new code that I'll be working on, I'll upload in the same folder as deployment.ipynb. And so there will be another folder, or you can say branch within this, which will have my deployment codes. Okay, all good? Okay, perfect. So what I have done here is the very first thing, if you want, I can just pull out the first part, because that has the bare basics to understand what we are doing. Okay, so I'll just pull out the first part. This is running on a cloud environment. Okay, what I've done is just cloned my entire repo on this another cloud. Okay, last time also I had mentioned I'm using Jarvis Labs, and today I'm using the CPU version because I'm not going to spend time on model building, so I'm not using a GPU today. I'm going to use a CPU. Okay, and there are some questions in the Q&A, so I'll answer the Q&A as and when it is needed. Okay, or as and when I get some time. So I'll just look into a high level of what the questions are today. Dinesh is asking for a high level idea in the last sessions. Okay, that I do, don't worry. So which is the best website to learn NLP? Okay, the resources we'll discuss at the end. Dr. Rajita. And Gulzar has asked, which services are we going to use? AWS for deployment. The only service that we are going to use is EC2 instances. Just that's it. Okay. So we'll be only using the EC2 instances, and just to add to that, if I remember, sorry, not here. I think I had also provided a link for a couple of documents on how to get started with a new AWS account. Okay, so these are the 3 documents, 3 links. This is how to create an account. You will have to probably map your credit card. Okay, I'm not very sure, but you probably might need to add your credit card, although it won't be charged. Okay, but they need to have some of these. And then how to create a new instance, how to launch it. Some basics are there, although I'll start from scratch, don't worry. And then we'll be using a Linux instance instead of Windows. That's a bit buggy, and a lot of configurations are needed for a Windows instance. Linux is pretty good for this kind of task, I would say. So we'll use a Linux instance, and the machine that I'm using is a Windows machine. So now how do I connect my Windows machine with a remote Linux instance? For that, we'll be needing putty or something similar. Okay. So that is mentioned in the 3rd link. So this is all about the prerequisite kind of thing. If you have followed, well and good, you'll be able to really follow along with me. If you have not been able to create and get sorted with your account, at least watch it. Okay, and maybe once the recording is uploaded in 3 to 4 days, please do not keep this asking for this. It takes 3 to 4 days, at least 4 days for the recording to be uploaded. Okay, it will take at least 4 days because the recording will be processed, some editing might be needed, and then it has to be manually uploaded in the channel. So these guys will share the recording link with you, but that may not come up immediately. Okay, perfect. So once the recording link is there, go through it and try to do it hands-on. Fine. Okay, so coming back to the model part then. Okay, let me open the first part to set up the context. I'll take not more than 5-6 minutes. Any questions on the chat box? Sheikh is asking, can these model deployment in machine? Yes, we'll start with ML model and move on towards deep learning. And at least we should be able to deploy one machine learning model. And if time permits, I'll also try to deploy the deep learning model. Or even if we don't get time, the process more or less remains the same. So you would get a framework, how a model deployment works in the most basic form. So this is at a beginner level. Today, I am taking this session at a beginner level without any prerequisite on deployment at least. If you're familiar with ML, because I'm not going to discuss any algorithm here. I'm not going to discuss what is deep learning, because these were all covered in the previous 3 sessions. Okay, so I'm not going to invest time in that. Rather, if you are aware of these terms, how can you quickly create a model, validate it, and deploy it? That is what the next 45 minutes or 1 hour would be, engaged in. We'll be using Flask, Nitin. Yes, absolutely correct. We'll be using Flask and we'll deploy the same Flask API on the AWS cloud as well. All good? Let's get started. Okay, so this code is already there. I am not going to run any of this. Just, to give a quick context. Okay. There is one more question from Ahmed. Can we use Django? You can very well use Django, but Django, the only problem is it is not beginner friendly. Okay. So it is good if you want to create complex projects. When I say complex project, means your ML model is also interacting with databases in the live environment. Okay. So for example, think about a scenario where the user is giving some query. That query goes to the model gives some prediction. And then if the user is just happy with the model's predictions, fine. If that is what the session is, Flask will do. But if you want to save all the queries which users are, continuously fetching the predictions from the model, okay, you want to keep saving all those queries, then you need to connect your model with a database. For that, you'll need a more elaborate model building framework, I would say. You need, if you want a lot of HTML templating, okay. Third, if you want to also implement authentication. So, for example, your model cannot be accessed by just any random person on the planet unless they have authenticated their session. So, if you want to create sessions, if you want to have authentications, access tokens, these things can be implemented in Django very easily compared to Flask. I mean, managing access tokens and sessions, these are very flimsy in Flask. That's per my experience. So you don't need Django until unless you are not doing any of this stuff. That's your answer. Yeah. So that's a quick comparison between Flask and Django also. That's a very relevant question, so I took it upfront. Okay. So now no more questions. I mean, after 15 minutes, let me first finish with this. Okay. So yes, this is the tweets dataset that we have downloaded. And this tweets.csv file is already there in the GitHub repo that you can download it again. And now these tweets are about some mobile phones. These are some iPhones, Android phones, and users are talking about some features of these phones, right? So you can see all sort of hashtags, user mentions, @ signs. You can also see some hyperlinks and a number of stuff, right? So this is how your raw tweets are looking like, okay? Then some basic data exploration, you can see that roughly, if I show you the breakup, 75% of the tweets are positive. 0 here is positive. Please remember the 0 here is positive. I think mentioned it somewhere upfront. 0 is positive and 1 is negative. Okay, so just remember this. Yeah. So 0 is positive sentiment and 1 is negative. So we have the labels also, right? So 75% are positive and 25% are roughly negative. You can see from the value count plot, and there is value counts also mentioned. Then all sort of data cleaning. I wrote a cleaner function. So this was done in the part 1. I'll directly jump onto that cleaner function. Yeah, so here I've got the cleaner function where I'm removing all the apostrophes, then I'm removing all the hashtags, then I'm using all the user mention @ username. I'm removing the entire user mention. Then I'm removing all the URLs which start with HTTP something. Any URL which does not start with HTTP is still somehow able to make it. Okay, fine. So there are many more regex operations you can do to capture those kind of URLs. Here I'm taking a basic URL capture, and then contraction mapping is there, and then I'm just retaining only those characters which are small a to capital A. I mean, which are alphabetic. Anything which is not alphabet, that could be smileys, that could be punctuations, that could be numbers, all those are replaced with a white space. Can you see the white space? Right? And finally converting everything into a lower case and stripping any additional spaces. This is the basic cleaner function. And finally, I am doing some lemmatization. So I'm not going to discuss what is stemming, lemmatization and all that. That's all discussed in the part 1. And then I have got the clean tweets. I applied, saved it. And now you can see we have the tweets, the raw tweet and the clean tweet. And then this cleaner function was slightly tweaked, made better. And there's some data visualization going on. So please help yourself. I'll directly move on to the part where, okay. So we have the raw tweets and clean tweets without the stop word removed. And the third column is after the stop words are removed. Okay. So what are stop words? Again, that's a part of NLP. Stop words are mostly those most common words or frequent words that will appear in your natural conversation, which may not have any sentiment attached to it. So for example, you, me, a, and the kind of words which do not have any sentiment attached to it. They are not discriminatory. So you can remove them. Idea is to have minimum number of words in your vocabulary, because these words in the vocabulary will finally turn into features. What is vocabulary? Vocabulary is the collection of all the unique words in all the 7,920 tweets. Okay, it's a collection of all the unique words in all the 7,920 tweets. That is the number of tweets here, right? You might remember. So I want to have, meaningful words in my vocabulary. Okay, and what I did was, finally, when I tried to explore this, we got roughly 16,000 unique words in my vocabulary. Okay, after all the data cleaning stuff. And 7,920 is the total number of tweets. So then what I did is applied a count vectorizer. What does this do? This converts your unstructured data. So your clean tweet is still text, right? And each of these text has got different number of words, different number of characters, different word length, character length. So this is the unstructured data. So we want to convert this unstructured data into a structured format. What is structured format? Where you have rows and columns, proper tabular format, right? Rows will represent each data point. In this case, each data point is a tweet, and the columns would represent features. I do not have any features. So what does the count vectorizer do? In simplest words, this is a feature extraction technique. I'm using count vectorizer to extract features. Okay, so that's very clearly written. And there are many strategies. So all those strategies we have discussed in the previous sessions. So after I run the count vectorizer, this is the kind of features I'm getting. So it's sort of a one-hot encoding. Think about each word, and then I'm representing each of those words from the vocabulary in the document by using a sort of a one-hot encoding scheme. Right? So I've got this structured data, and then the model building started, where we do the test train split. I use a logistic regression, train on the training set and test on the test set. It is as simple as that. And then cross-validation was done by using cross-validate function as well as cross-validation score function. And for cross-validation, I'm using the stratified k-fold so that each of the fold have the same ratio of the positive and negative tweets as in the original data set, right? So here is the cross-validation code. And I've got my 5-fold cross-validation accuracy of the logistic regression model as 88%. Here I'm using the solver as liblinear and the penalty function as L1. So this is the regularization I'm going to use. And why I'm choosing L1 over L2 is I have so many features, roughly 16,000 features. So I want a built-in feature selection, which lasso kind of regression has. This is not exactly lasso, but the penalty is still the same, right? So it's a lasso penalty included in a logistic regression, correct? So this lasso penalty or L1 penalty will make the coefficients to literally 0 against those features or words which are not very important to this model, which are not discriminatory words. So all the non-discriminatory words, words which cannot discriminate the sentiment of the tweet, those non-discriminatory words will have model coefficient as 0, literally. And then I did some tuning, manual tuning in fact, and came up with a C value. This is your penalty parameter of 0.4. and then you have it. Somewhere down the line, I did a hyperparameter tuning also. I'm not going to repeat that. And finally, I also created a pipeline, which I'll just quickly show. So here is the pipeline, which I'm going to use it for final model building. Okay. So here I've got the X data, Y data, count vectorizer. This is for feature extraction. And then this is your estimator. So this is the transformer, which is going to convert your unstructured tweets data into a structured format, means rows and columns properly, each feature occupying a single column. And then you have the estimator. So this is a very simple pipeline where you have the transformer, your feature extractor, basically, this is a feature extractor followed by an estimator. So the extracted features will be directly given to your logistic regression estimator, and finally you will get the model. So you can directly fit this model as a pipeline also. You can do this pipeline.fit, pipeline.predict also. So that's what I'm going to do next. So I copied this part of the code in my next notebook. Okay. So let me directly switch over to the next notebook. No more experimentations we are going to discuss for this notebook. Perfect. So what I did was I created another notebook for deployment. Okay, I'll just switch on to that. So this notebook is not yet uploaded in Git. So please pay attention here. I'll upload it after the session. Okay, so please do not keep requesting. I might be doing a lot of changes during the session, and whatever is the final notebook that we end up at the end of the session, I'll just push it. Okay, so don't worry, everything will be shared. So I have all the necessary stuff. Okay, you can see. And then here I have, so what I did is, after doing that data cleaning, I saved my data frame, this data frame of cleaned tweets, this data frame of cleaned tweets was saved. And saved, the better term or the correct term is serialization. So when you are saving a data frame into your hard disk, that is called as serialization. How do you serialize? Let me share a part of the code also with you. So here also somewhere it might have been done, but don't worry, I'll show you how it can be serialized. So this is what dumped into your, this will be this data frame will be directly dumped as a data frame, as a binary object, you can say, which Python can read, of course, and the file format would be a pickle format. So in one line, I am pickling this data frame for later use. So you can call this data frame directly. You don't have to run all the cleaner functions, nothing. You can directly start from this point. That is the whole, objective and the biggest advantage of doing serialization. So I just dumped this entire data frame into a pickle file, and somewhere down the line that pickling code is also there. So don't worry, how did I do that? It is already there. Okay. So I'm just reading that pickle file. Okay. Or if you want to do it, let me just run this. Okay, fine. So here is your data dot head. I'm just displaying the top 10 tweets. I have deleted, I've completely dropped the raw tweets, and I have got two versions of it. One including the stop words, second version with the stop words removed, and the third version stop words removed and only retaining those words which have a length greater than 2. That is why this is called as SW removes length GT2. Once again, I repeat, I have got 3 versions of my clean tweets. Okay, and all those cleaning functions are done and discussed. Okay, so I'm not going to repeat all that. So this is your clean tweets. Cleaner functions are already discussed in the part 1 and part 2, including the stop words. This is the clean tweets with stop words removed. In the count vectorizer also, you can remove the stop words, by the way. And further, so this will have less number of words automatically. You can very well, imagine, figure out. This is the same clean tweets as this, but any word which has got a length less than 2 will be removed, will be skipped. So let me show you one of the tweet, probably. Okay. So there was a C-type charger somewhere. Someone was mentioning C-type charger, but that did not make up to the. Can you see this C charger? Can you see this C charger? Now this C will get dropped. This C will get dropped. Okay. So this doesn't appear in the next one. Let me show you. Can you see that C is gone? Perfect. So now I think you get the point. Yes, UK is also there in the same tweet. UK is also there. See UK Bay. So now can you see this UK Bay Amazon is there, and that UK is also gone. So between cable and Bay, UK was present, right? That is also gone. So I think you get the point, right? Perfect. So country names and all that will not have much sentiment information. So that's the reason I safely just dropped it, just to decrease the size of my vocabulary, because bigger is the size of the vocabulary, more is the headache, more is the dimensionality of your thing. Basically, more will be the number of features. So if you have 50,000 unique words in your vocabulary, you will end up with 50,000 features. So I don't want any random word to just, make it to the vocabulary. Perfect. Then usual, again, imports are there. I am just taking the last column. I'm just taking the last column. But if you're still wondering how did I save this data frame, let me show you. .to_ pickle function is there. Can you see? .to_ pickle, and you can save this by whatever name. Okay, you can save this data frame by whatever name. Okay, let me check if it got saved. Yes, can you see on the left top? It just got saved from here. Bingo. Yes, it is that simple and such a lifesaver, because now you can import any data from a different notebook and just immediately start using it. Perfect. So that is what I had done. Okay, there is another way, but for data frame this works the best. If you want to serialize a model, or if you want to serialize the vectorizer, or if you want to serialize a dictionary, then probably you will need the pickle module. Okay, so only this part, which I just copy pasted from the previous notebook. I hope this is very self-explanatory. I have the X, the k-fold object, count vectorizer, and this. I created the same pipeline, did a 5-fold cross validation, and then I am getting decent 86% accuracy. The only difference here from the previous code block is the max features. So I'm restricting it to the top 1000 features. That's it. In the previous case, it was roughly 16,000. I'm restricting it to the top 1000. For that reason, the accuracy is slightly lower. There it was 88%. Here it is 86%. That okay, fine. I just want the performance right now. I do not want to invest too much time. Okay, because this is not a model building session. So I'm just trying to save on some time. And top 1000 features is also good enough. Okay, perfect, perfect. So any questions still here? Let me take a quick break. Okay, any questions still here in the chat box? So Bobby is asking, how have you created 3 columns in one cell? No, it's not 3 columns in one cell. It's basically 3 columns for every data. So those previous notebooks already have that. Okay, so just follow that previous session recordings. You will be able to create new columns and dump your cleaned tweets into columns. So that those codes are there anyway. So Mike is asking, health, I guess probably some of the, see, we had used lemmatization. So the problem with the stemming and lemmatization is that it may not retain the entire word. Something might get stripped off. So it might be just a artifact of that also. So plus, since these are tweets, so people tend to use short forms. So I'm not very sure where is that coming from. So Gulzar is asking, is it necessary to save in pickle, or we can use CSV? You can save it in CSV very well. The only thing is CSV will take more, time and memory, both. Okay, this is a binary format, so this is more reliable. See, as long as you do not want to share your data with someone else, let's say your friend or your manager who does not want to use Python at all, okay, I would always try to save my data as a pickle file. That's my by default behavior. Okay, because not only I save memory while saving, but also I save memory while loading, and the file size is also small. Okay, so if I'm doing it for myself, then I'll always go for pickle file format, right? Unless you want to share it with someone else who doesn't want to open that in Python, right? So then CSV is a better choice. Okay, perfect. And good. So all the questions are answered from the Q&A. Anything in the chat box? One question is there from the YouTube side. Okay, how will you transform data before prediction if we deploy the model? Perfect. That's a very good question. Okay, so we are going to save our instance of this vectorizer, and that's the reason I am going to serialize the pipeline. Okay, once again, that's a very, very good question, in fact. Okay, whosoever asked it in the YouTube, it's a very good, very well thought of step. So what that person is asking is, for example, this is the tweet. Okay, how do you make sure that this tweet undergoes the same steps of cleaning? Okay, so there are two ways. One, you can copy that cleaner function and paste it in your Flask application. Along with the cleaner function, okay, you will need your vectorizer, because so right now I'm using a very much cleaned tweet. Can you see? This is my test tweet. So this is my test tweet, which is very much clean. But if this is not yet clean, you will still need that cleaner function to clean it. So what you can do is you can just copy that cleaner function to your API also, because it's a function, it's a standard Python function, right? So it can be copied from that notebook to your Flask notebook also. Simple. But that cleaner function is not sufficient, because your model cannot predict from the text, although it is cleaned. Okay, once again I repeat, your model cannot give a prediction from the clean tweet because it is still unstructured. Model has learned from the features, which is a structured data, right? Your model is learned from the features which is structured. Your features are being generated by the count vectorizer. This is the guy who is generating the features, right? And the model is learning from those features. So you should be able to extract similar features for any new tweet also. So this is a new tweet, although it doesn't have any surprise element. So if you want to clean the tweets in real time, you will need that cleaner function. So that is one additional step that you will have to do. And right now I have just saved my time. And then you are using the predict method from the pipeline. Let me show you this. Okay, so, and I get the prediction directly, 0 or 1. Fine, this is the prediction that I'm getting directly. So what happened is this clean tweet directly goes to the count vectorizer where features are extracted, and those extracted features go to your estimator for the predictions. Those estimators for the predictions, right? Same step, same step. First features are extracted by count vectorizer, and then they are going to the estimator for training, for learning the pattern. And now what does happen here? The same dot predict method. So please pay attention, the new guys at least, okay? You might have not done this. So I am running my predict method not on my logistic regression. I'm running it on the pipeline. So it's like pipeline.fit and pipeline.predict. That is one of the best reasons to learn to use pipelines. This is how a pro level code, a machine learning code would look like. What do the beginners do? Your machine learning model.fit on X-train, Y-train, and so on, and machine learning model.predict. Okay, and then you have n number of steps to take care of. So the better idea is put all those steps within a pipeline. Use the pipeline for final fitting and use the same pipeline for prediction. Perfect. Any more questions? Okay, there is one more question from the YouTube side by Humaira Yasmin. What is the difference between pickle and py file? PKL is a pickle file. It's a pickle file. Pickle is your binary file serialized. So just imagine whatever data that you have dumped it in a binary format, which your Python environment will be able to extract and make sense out of it. Py file is a standard Python file. I mean, that's a script, Python code. So pkl is to save data, whereas .py file is to save your code, right? .py is how you save your code, and .pkl is how you save your data. Not just the data, but also some of these classes. Like now, pipeline is a class. So you want to save that pipeline, you'll have to serialize it. How do you serialize it? This is the part of the code. So import that pickle. I want to save this CV pipeline by this name, logistic regression pipeline dot pickle. W is for write, B is for binary. So I'm writing a binary file, okay? And I'm dumping this CV pickle by this name. So this is the name by which it will get saved in your hard disk. Okay, right now I am running this on my cloud. So you can always go for pwd and this will print the working directory. So if you are still wondering where is this getting saved, of course, this is the directory where it is getting saved. So if you still, get confused where is this getting saved, you can always do a pwd and make it out, okay? And how do you read that pickle file? Because we'll be reading this pickle file in my Flask application very soon, okay? So we are running out of time. Okay, so the only difference is here, instead of pickle.dump, I'm using pickle.load. That's it, that's it. So here I am providing my pickle file name, RB, R is your read and B is for binary file. So read binary, and then you have the pipeline. So here what I did is, just to make sure that the pipeline was imported correctly, I have the same LR pipeline. See, before this code, LR pipeline did not exist. Okay, so I am importing that pipeline from the serialized file and then using it for prediction, and I'm getting the same answer. Absolutely. Yeah. So if you want, I can run this code once again. Perfect. So that works. And I can show you that these serialized files are somewhere here. Okay, LR pipeline. Fine. Perfect. Moving on to a very simple deep learning model, because in the previous session, the part 2 and part 3, I have created enough deep learning models. So I'll just show you how you can create a very simple basic deep learning model and save it, because that is also needed. We need the saved model for deployment, right? So here the takeaway is not how to create a deep learning model. The main takeaway from this part that I'm going to discuss about deep learning is how to save and be able to use it. Okay. Usual imports are there. This is a function which will define a very simple deep learning model. Okay, so in this model, I'm using the sequential class. So I have the first hidden layer with 64 neurons, and then using the activation function as ReLU and kernel regularizer. Then the second hidden layer has got 32 neurons, and this is my output layer with a single neuron, because this is going to give you 0 or 1 as the prediction, right? And this is your sigmoid activation function. And then compiling the model by using binary cross entropy, because this is a binary classification problem. For multi-class, you will use categorical cross entropy. You can experiment with the optimizer, ADAM, ADAGRAD, ADA-delta, RMS prop, a number of NADAM is also there. Okay, so several optimizers are there. And then what accuracy metric you want. So I'm using here as accuracy metric as accuracy. So if you are interested, you can replace that by F1 score also, or precision, recall, AUC, ROC, whatever metric you want. So I just want to keep things simple. So I just made it accuracy. Summarize the model, and here is the plot model, which will print a summary of that model in a graphical format, saving that model here so that I can load it later. And then I have got the tokenizer function from your Keras, which is the main function which will convert your unstructured tweets data into a structured format. You remember the count vectorizer? This is the equivalent of count vectorizer in deep learning. Okay. So I'm just using that tokenizer function. And when I do a create tokenizer, so this is the function I'm running, create tokenizer on the training docs. So it will, create my X train kind of. Okay. So I'm using again the third column. So this is becoming my training docs, and this is your tokenizer instance. Once I use the text to matrix tokenizer instance for the tokenizer instance, mode here can be 4. So either it can be binary, it can be count. If you make it as count, then the output will be exactly same as count vectorizer. Binary is same as one hot encoded. So there are 4 options in this. Once again, in binary case, it will be as simple as one hot encoding of your text. Count vectorizer. So here you can replace it with count. Third, TF-IDF is also there. So then it will return the TF-IDF scores of all the words in a given document from that vocabulary. And the fourth option is frequency option. That is basically your normalized counts. Okay, so after running all that code, you can very well see that I've got 7,920 tweets, and how many features it has been able to generate? 13,634 features. Here I'm not restricting the number of features. Okay, fine. So you can see each of the features is just a bunch of zeros and ones. 0 means that particular word is not present in the first document. 1 means that particular word or feature is present in the first document. X0 is the first document. I'm just displaying the first document here. Y is your label column, and just doing a test train split. Okay, and then training the model on the training set and testing the model on the test set. So here I'm creating the model, clearing the Keras session. And then you can see I have got 874,000 parameters to be trained. This is how your model looks. Okay, it's a fully connected dense layer. Okay. I think I will have to. So this is not the correct one. Just replace this with the correct one. Okay. How do you know that that was not the correct one? See, the number of features has to match, right? How many features we had? 13,634. That many number of features we had, correct? The features have to match. 13,634 features. Training set has got 6,336. Test set has got 1,584. The features have to match. Now in this, you can see 13,634 features are matching. So this is the correct image. Okay. And where is it saving? Plot model 1. So if you see, this is the plot model 1.png file. So it is creating the model, saving the model flow chart in this the PNG file. And here, what did I do? I just created a markdown cell and just dragged that PNG file and executed that cell. This is how you can display your model. Then created a checkpoint to save the best model by monitoring the validation loss. So whichever model gives me the best or the minimum. So here the mode is minimum. So whichever deep learning model gives me the minimum validation loss, that will be serialized as a H5 file. That will be saved in your hard disk as a H5 file. Here I have mentioned save best only true. So I'm not interested to save all the 25 models. Why 25 models? Because this is going to run for 25 epochs. So if you make that false, then all the models will be saved. Okay. So that is what I do not want. I'm going to run 25 epochs of training, batch size of 180, verbose 2 and all that. So you understand? Okay. So creating that checkpoint as a callback function, and that callback function is now given to your callback argument. Fine. So this is all regular stuff we have discussed in the last session. So finally, I get my model, and let me show you that model has got saved here. Best model.h5 file. Okay, I'm not going to run this because this might take another 10 minutes. So best model.h5 file, this is what you get. And then you can plot the accuracy and the loss function values with the epochs that has also been discussed. So basically, whichever model has got the lowest validation loss is what I am going to say. Let me test the model on the test set because I had reserved 20% data, right, for final testing. So this has given me 88%, which is very good. Okay, so 88% accuracy on the test set. This test set was not used during the training. Okay, so we had taken another 10% as the validation split. If you noticed, I took out another 10% for validation from the training set itself here. Good. Okay, so this is what it is. And then finally, how do you check any? So what I've done here is, okay, so this is evaluating your model on the entire test set. And now there are a couple of test tweets I have given. I just copy pasted from the data frame. Okay, and just making sure that they are in the right format, and just import Keras, load the model from the best model.h5 file. So this is how you would load the model. So this part of the code will go into your Flask. Okay, because Flask application will only load the model and directly give the predictions. So which part of the code will be there in the Flask? This part of the code. Okay, and the prediction part of the code. Only these 5 lines would be there in a Flask application. That's it. Okay, so you are loading that model and then passing your tweets. Okay, in the vectorized format. At max, you might need the tokenizer also. So what I've done is I have saved that tokenizer also as a pickle file. I'll just show you. So I have saved that tokenizer. Why is that tokenizer needed? Because this tokenizer will be creating features from your textual data. Otherwise, your Keras model cannot give you the predictions, right? Keras model has learned from the features. So it needs the same kind of features. So you will need that tokenizer. So I have serialized the tokenizer. Sorry. I have saved my tokenizer also, and I've saved my Keras model also. 2 things I've saved here. So advantage in that ML model was the tokenizer or the vectorizer was saved along with the estimator in a single pipeline. Here you will need both separately. That is the only difference, right? Once again, I repeat, in your ML, you had saved your tokenizer or your vectorizer or the feature extractor as a pipeline. So back to back, the feature will be extracted followed by the model's predictions. Here, both these 2 things have to be saved separately. So instead of the count vectorizer, I have my tokenizer. So I have serialized my tokenizer function. Okay, I've saved my tokenizer function. And how do you use it? Again, import that same code as I have shown before. And once you have imported it, you'll use that tokenizer function to tokenize your any new tweet, get the features. Once you get the features, you can use your saved model and get the predictions. So how do you get the predictions? Same, get the predict method and then convert that into a, this function will give you a probability. Only problem is this will give you a probability. So that has to be converted into a final label. For that, I'm using this rounding function. So predicted label is 0. Okay. Predicted label is 0. So there are 2 outputs. One is the probability value, which I'm rounding. Okay. And the predicted label is 0. Okay. So this is my predicted label here. So don't get confused. Perfect. So this is all the necessary, requirements before we move on towards the Flask. Okay. So I'll just show you. We have the pickle file, the logistic regression pickle file, the tokenizer pickle file is there. Okay. This will be needed for your deep learning model and along with the H5 file. So these 2 files will be needed in your Flask. You won't need the tweets. You won't need this pickle file. No, this is needed to create the model. You have already created the model, right? So you will not need this pickle file anymore. Right? Delete this. Perfect. So now let me just share the Flask part. Any questions in the meantime before I move on towards the Flask? So, okay. Yasmin has asked, what is protocol? So, okay, basically, there are different modes of saving. So I'm using the highest protocol, means it tries to instruct the processor that while serializing, do it in its native format without any packet loss, okay, or data loss. So it's a lossless serialization. So that is what that protocol is instructing. And another question is, how will you identify if there are multiple labels and fetch the label names? So that has to be done manually. I'll show you that part of the code is also there in my Flask application. That has to be done because zeros and ones, user will not know what is zero and what is one, right? Okay. Now to make things simple, okay, this is also a tweets data set, and the Flask is a completely different skill set. Okay, so there are three skill sets we are discussing in this today's session. One we have discussed. Now, second part is the Flask, which I'll take another 5 to 10 minutes. And then another 10 minutes I'll take is the deployment. So this is the three parts we are discussing right away here. Okay. Okay. So those files. So do you guys have any idea about model deployment, first of all? Very basic question. Has anyone ever written a Flask code before? Yes, no. Okay, so there are a few people. Fine. So for that, we will be moving on towards Spider now. Okay. So we'll be moving on towards Spider. Fine. Okay. Okay, so first thing is, if you want to see how a very basic level code is written in Flask, let me just open a different. Okay, let me show you how this works for the people who are completely new to Flask. Okay. So this is how the Flask deployment code might look like. Okay, so I'm importing Flask. So Flask is going to wrap your model and serve it. This is more of a development server, not a production level server. So there's this kind of message you will get it. Okay, so this is the decorator function. This is the decorator over this function. So that is what we call it technically. But why is this being used? So this decorator creates an endpoint. Endpoint is your entry point. How can you access your model by using what kind of address? This is like your web address. Okay, slash represents the root. That represents the root of your website. So anyone who goes to the root of your website will be able to see this hello world. Okay, fine. And then we have one more route here. So this is also called as endpoint. This is another endpoint, and this is your home route, which is another endpoint. So there are two active endpoints. There is one endpoint which I have just commented on. Fine. So this endpoint will be able to get data from the okay. Let me activate this as well and see what we have. Okay, I'll just save this. Okay, and so there are three endpoints. So maybe I'll show you the output, and that will be very much self-explanatory. So how do I run this? I'll just click the run button over there at the top. And if you okay, so right, this is what is happening. I just uncommented that, and there are two functions which are overwriting each other. That was the error. Now, if you see that on the console, I see a message that it is running at this link. Don't use Control C to copy that link. Use right click and copy. If you use Control C, it will stop that server. So what you have started is a Flask server there. Okay, let me show you how that Flask server will look like. So I'm just pasting that link. Okay, and that is taking me to the root. Can you see if I just put a slash here and press enter once again, it refreshes and gives me this message in H2, hello world. If I try to inspect or see the source code of this page, I'll get exactly this, H2 or H1. It is H1, hello world. So this is the message when I get when I directly access the root. This is the root, ROOT, root endpoint. Okay, so route is to create the endpoint, and which route you are accessing, that can be specified by the endpoint. Now let me go up and put a slash, and if I do add, okay, let's press enter. What I get is 30. Can you see this 30? Now why is that 30 coming up? Because now it is invoking this function. So each endpoint is invoking a function. Can you see? That is what the decorator is doing. Once again, this is at a very, very basic level. Okay. So each endpoint is invoking a function. So this slash add endpoint is invoking this function. So you are getting the output from this function. Literally, yes, you are getting the output on the web page from this function. So what is this function doing? This function is taking two numbers A and B and just adding those two numbers, converting it into a string format, and then putting a H1 tag before and after. So this is like a HTML tag before and after. And this is just returning that S2. So this S2 has got the HTML tag along with your output 30, right? So that is being computed by this app route. Okay. So that is why I get 30. So this is still not very helpful because it cannot take input from the user. If you want to take input from the user, now pay attention. I am going to use my third number, that is add_new. Let me press enter. You'll get an internal server error. Okay. And I'll show you that error message is also going to come up here. Can you see on your right side? This gives me internal server error 500. Why is that error message? Because it was expecting two inputs. Which are those two inputs? Those two inputs are the values of A and B. Can you see here? You are requesting two arguments, A and B. Those two arguments has to be given by the user to the Flask server. Okay. So how do I give those inputs? So I'm going to see, please pay attention at the address bar. I'm going to use question mark A, assigning it to A1. Okay. And here you are collecting B, assigning it to B1. So here in the calculations, you should be using A1 and B1. Correct. So this was so I made this change somehow and I also forgot. My bad. Sorry. Okay. So this should work. Let me stop so for every, change in your code, you have to stop your server and restart it again. Okay. So how do you restart? Just click on that start button. That should work. Okay. So that is how it restarts. Okay, so I'll go back and first we will see in the browser and then we can still see it in the Postman. Okay. Okay, it's already there. So I think I'll have to just refresh this page. First check. The root is running. This is add new. That is where I made this change, right? Add _new and then question mark A equal to 100 and B equal to 50. Oh, that is still giving the same. Any other? This should have worked, definitely. So here you are collecting the value of A and B. assigning it to A1 and B1, computing by using A1 and B1. So A1 and B1 are now available locally. Should have worked. Let me see. Is there anything which I'm missing? Oh, okay. So probably I'm missing the requests, okay, which is what the error message is saying, okay. I keep modifying the code every other time. So from here itself you can. So within Flask itself, you have the request, I think. And just check. Yeah, from the Flask itself, you have the request. Okay, good that we are making these mistakes right now, so that you know. So it all happens. Okay, so let me directly move on to this and just refresh. Everything worked. This should. Okay, so two mistakes we were doing. Number one, so this is the learning with live sessions. Okay, so you make mistakes, learn it, because I keep modifying these codes for every other session just to show them, and I also forget sometimes. Okay, okay, so we got it done. Okay, so if this is working, that means now our model should work definitely. Okay, so what I've done is I have created a ML model. So okay, so we have good number of participants still there, although I'm exceeding on time. So now from here, I can directly move on towards the model part. Okay, so here, okay, I wanted to do a quick demo on Iris dataset, but okay, that's not needed. We can directly use our model file. Okay, so I'll move on towards my app. Okay, not this, not this. On the right file. And you can download all these files. Let me show you that code if you want to do it right away along with me. So if you go to another repo here, it's present as model deployment. Okay. So it is present as another, go to the repos. I'll just clone that repo. So this is the repo where you have all the codes for the model deployment. Okay. So I've created a naive based classifier. Okay. And the data set that I have taken is a spam message spam detector kind of. Okay, so the problem statement is same. So I encourage you to actually create. So we have already created the model, and then I have serialized that model. Only difference is I am not using that logistic regression right now. I'm using naive based, so that's just a difference of the estimator. Second difference here is I'm not using a pipeline because there's no reason for it. It's just I got a bit lazy. So what I've done is along with that, I have also serialized my count vectorizer. So two things I have separately. Okay, so I would encourage you to actually use the logistic regression here. Okay, where I'll just show you. So I've got two things serialized. One is the vectorizer, and here is my model. So two things vectorized, sorry, serialized. So you can directly, I'll just share a link for this. You can download all the files right away, and this is the one which we'll be using ahead. So I'm just pasting this link. So please download that. And I think this will now also appear in the Postman, because that was that silly mistake we were doing. You can very well see this in the Postman. So what was that? Add underscore new. Let me just see if that works here in the Postman. Postman is a very good way of checking. You can see this is the result that we have got. And if you go to the preview part, we'll get the answer here. So this is the best thing. You can pass the parameters by using their keys directly. Okay, that is a very easy way. You don't have to type it in the address bar. So all you have to do is just paste the root link, app root link, and all the parameters, whatever you keep on adding, that will get automatically populated. Okay, that's the thing. So I mean, I can go on. There are many variants of the same app, but we'll directly move on towards the main thing here. I'll open this file. So I think I have got saved this, or let me just download this. Save file, the fresh file, because I might have again changed it, and I might have forgotten. So model deployment. Spam, let's call it a spam. Let's just unzip this. Okay. And extract all. Extract. I'll head on towards, okay, fine. Towards the Jupyter notebook. Mayank, this is a naive-based classifier, standard scikit-learn library. You will have it, right? Naive-based algorithm. So advantage of naive-based is it's actually surprisingly very good with textual data, and it's much faster compared to other deep learning models, and results are also very good. Okay, we'll not get into discussions of the algorithm, but you can just experiment different estimators. Okay. So process is very much the same. You need that pickle file. Okay, so I'll directly move on to now that folder. So browse onto that folder. So earlier I used to show the deployment by using Heroku Cloud, but Heroku recently has done some flimsy changes in their integration of the payment method, which is not in compliance with the RBI guidelines. So that is the big problem. And so okay, so let me copy this. It here. Okay, so these are the files. This is my app file. This is my final app file, which will serve the model. Okay, so let's see. I am importing Flask, and there is a render template. So I'll tell you what is that for. Pandas, pickle, because I'm going to unpickle it. Feature extraction, count vectorizer. Okay, if you want, you can do that, or you can directly import it. So this is not actually needed. Maybe I can just comment this out. And this is also not needed because you are not going to create the model. So these two things are not needed. Okay, so there is a home which is going to serve a HTML template. So let me directly run this and show you how that comes up. And then from here you are loading the model. So pickle.load, open that model. RB is your read binary file. So read a binary file. So you are reading your pickle file. This is a model file. I am calling it as classifier. And then you have the cv.pickle. This is my vectorizer. What am I doing? I am getting the message from the HTML template. I'm getting the message from the HTML template, dumping into a list, okay, and passing that to your count vectorizer. Okay, converting that into an array, because the output of the count vectorizer is a sparse data, and you cannot directly pass that sparse output to your estimator. So you have to convert that into a dense format. So that is what this function is doing. It is converting your sparse output into a dense format. All these I have discussed in the part 1 and 2, so I'll not repeat them. So this is your final vector for your tweet or message, whatever. So this is your vectorized message, okay, or vectorized tweet. When I say vectorized, it is your 1 cross whatever 10,000, 13,000 number is. Okay, this is your features coming from your message. So you are passing those features to your classifier predict function. You will get the prediction, and you are simply printing the output. Okay, so this output is now captured by your HTML form. Okay, and there is a prediction, field in that HTML form. I'll show you that. So that field will process that, and there is a if condition that's written within that form. It's a JavaScript, a small JavaScript, okay, which will convert that into a message. So I could have done it here also, but I'm doing it in the HTML form. Okay, so this is how you would simply serve your model. This is one way. The many ways, but this is a more decent way because I'm using HTML form. Without the form also you can serve it. Okay, without the form also you can serve it. Okay, but this is a better way because the user doesn't want to use those question marks, something. That is not very handy for the user. That is the very reason I'm using a HTML form, right? For a user, this is much more handy. Okay, now let me run this. Okay, so the previous one is already running. So let me close that server and run this file once again. Okay, now that is running at HTTP. So do you want to test it? No, so we don't need Postman to test it because this has a HTML form. So okay, let's go ahead and paste that link in the HTML form. Or the HTML form, sorry. I've just pasted it. Let's see what comes up. Perfect. So here you can put whatever thing you want. You can put whatever thing you want. All you have to do is just go to the source. So you can directly go to the source here. Not very difficult. Let me show you the source also. So it is present within the templates. There are two files. One is the home, which is being rendered right now. This is what is rendered right now. This is your home. If you open it using Notepad, you will see the HTML code. Okay, let me try to open it in the Notepad so that you can see the HTML code. It's a very simple HTML code. Okay, so you have usual head, okay, where you are attaching a style sheet. Now, why is that style sheet needed? This beautification is done. This beautification of the web page is being done by a CSS, cascading style sheet. You are attaching those style sheets here. Okay, in the head part, you are attaching those style sheets, correct? And where did I mention that? Here. Okay, so this is where you are attaching the style sheet. And where is that style sheet saved? Within the CSS folder. So static folder, there is another folder called as CSS. That is where this style sheet is saved. Okay. So you have to maintain this folder structure. Please understand, you have to maintain this folder structure. What is the folder structure? Once again, you need to have two folders. One is for templates. All your HTML templates will be here, which will capture the user input, and there is one result file which will display the output of the model. So two files are needed, two templates are needed. One to capture this is going to capture the user's input, and the other one is to display the model's output. Plain simple. Number one, home is to capture the user input, and result is to display the model's output. Fantastic. And then you have the static folder where you are going to attach your style sheet. So this is where my style sheet is present. So I'm not going to get into the details of the style sheet. So this will, you can take any simple tutorial on W3 schools, how to create basic style sheets, or you can use the same style sheet, doesn't matter. Okay. Fine. So this is how it is. And if you go to the body part, I've created a small div, okay, for each of those. And then this is a form. Okay. And if you focus here, the method I'm using is post. This is the predict function. So it will capture the information from the user. It will capture the message from the user and invoke the predict function. So where is that predict function? Where is this predict function? Can you see this predict function is here? And the method I'm using is post. Okay. The post method I'm using post method I'm using, and it is invoking the predict function. Perfect. And then whatever that message is, this is the form and text area message, how many rows and columns. This is just to render a or create a text box. That's it. And finally, when the user submits that click, when the user clicks on this submit button, okay. So what happens? What happens is the value is predict function. So this is what will be displayed on the button anyway. So this submit button will invoke the predict function, and then when the predict function is invoked, all these calculations happen, and then the output, can you see the function is returning the output in the results.html file. So it is rendering the output in a different HTML file. So that HTML file will automatically load with the output directly printed. Okay. So first let me show you the output, and then we will dissect that file. Okay. How does that look? Okay. So hi buddy. Let's meet tonight for a drink. Okay. So it's not a spam. Fine. And then give me some message, a spam message. Okay. Give me some spam message in the chat box to try out. Hi there. You won gold. Okay, someone mentioned gold. Free offer. Send bank details. Anything else? Gift voucher. Whatever. Okay, let's see what comes up. So this is a very naive model. So I will not be surprised if it does not say spam also. Okay. Okay, perfect. Done. Okay. So this is a very basic model. Okay, don't worry about that. But the process is still the same. I hope everyone got the process. You have the tweets data, you have the pickle file, you have the class code also now. So as your assignment, replace this part of the code. Which part of the code? Replace this part of the code and try to use your logistic regression pickle file. Is that clear? Okay, so that part you should be able to do as an assignment. That's not at all difficult. In fact, that will save one step. Which step? Because I am not going to use this because it has a built-in count vectorizer. You are directly using the pipeline. Okay, so you don't have to do anything. This step is also not needed there. So these two steps will not be needed. Number one, line number 18 is not needed. The name of the pickle file will change, of course. And this line number 23 will also not be needed. Line number 23 will also not be needed because the count vectorizer is built within the pipeline. Directly that output will go to the classifier predict function. Perfect. Yeah, thank you so much. Thank you, Gulzar, Krishna Vini, okay, yes, thank you. Thank you so much, guys. Okay, perfect. So this is how it works. If you want, I can dissect my results file quickly. Okay, so just in a minute, view the page source. Okay, perfect. So this is the page source. If you saw here, no, but this is the output. Doesn't help. This is the output. Okay, let's see the raw page source. Okay, because that will be different. So that page source is after the output is generated. I want to see the page source before the output is generated because that is what you are more interested in. Okay, so let me open this in Notepad once again. Perfect. So more or less everything is same except for this part. That is what I told you, right? There is a JavaScript there which doesn't appear in the page source. Did you notice? Sorry. There is a JavaScript which did not appear. Because this is your rendered output. So in the actual source, there is a JavaScript, right? A very small JavaScript, if condition. So the prediction is 1, then change the color it to red and print as spam. That's it. And if the prediction is 0, then change the color to blue, print it as not spam. It is that simple. Yes, that's it. And where does it go? I'll just show you one simple thing. Where does it go? So it goes in the div class results. Okay, it goes in the div class results. That's it. Okay, and where is this prediction coming from? This prediction is coming from your model here. Can you see this prediction? Okay, so my prediction is the name of the variable, but where is that variable assigned to? That variable is assigned to another variable. Now, this is the name of the field in your HTML form. This is the name of the field in your HTML. So do not get confused. This is the variable in the local Flask application. But what is the name of the variable in your HTML form? Prediction. So that is what has to be mentioned here. Okay, because if you change this to prediction 1, 1, 2, 3, or whatever, this is the variable which has to be changed. Perfect. So we are done with local deployment. Now let's move on to the cloud. Okay. So yes, I'll upload. This is already there on GitHub. Okay, I have not done anything new. Okay, Ricardo, Sandeep. So this is already there in the GitHub. I have already shared the link. So don't worry, I'll share the link once again. Okay. So you can download this entire code from the GitHub link. So this is a GitHub link. So everyone, please download it from there. CLF is the name of the classifier variable that I have assigned to. Sorry. CLF is my classifier. So right now your classifier is a naive-based model, and the one which you have created is a logistic regression model. So it doesn't matter whatever be the model name here. I am locally referring the model as CLF. CLF is the local name of the model that I am referring to. Okay, you can call it as model, you can call it as model 1, 2, 3, you can call it as classifier 1, 2, 3, whatever. cv.pickle file is a count vectorizer. I told you that you can save your vectorizers or tokenizers also as a pickle file. Remember, you can save your model that also. So if you are saving your tokenizers, then you have to also deploy this. You'll have to upload all these pickle files to your remote cloud. You'll have to upload that to your remote cloud. Okay. So the better idea is to put all these pre-processing into a function or into a preprocessor. Okay, and put that preprocessor into a class. In the pipeline, followed by your estimator. So everything is in one pipeline, and then serialize that pipeline. That is the best practice. Okay, which is scalable. Rather than pickling so many vectorizers, transformers, scalars, encoders, one-hot encoders. No, that's not a scalable. That's not a viable option. Okay, perfect. There is one more question from YouTube by Yogesh. Is the code with percentage getting processed? A percentage there. Yeah, that says JavaScript. Yes. So I think you are talking about this. Yes, that is processed. That is the JavaScript which is processed by the server. Exactly. So right now your server is local server. It is local host, right? So it is actually being processed. Very good. Thank you for still being there. The session was till 8 and everyone knows that I never end in time, right? At least those guys who have attended my sessions. Okay, so no hurries and no worries. Which ID, the one used earlier in base, how is it different from another? I'm using Spider, so you can use VS Code or anything, doesn't matter. Vijay, okay? Perfect. Okay, and one more thing, we'll go back to the cloud now. I've already configured my cloud. Let me directly open that page where I have my EC2 instance. Okay. So if you have created your AWS account, because it's not within the scope of this session to teach you how to create an AWS account. That document was already there. Because that process itself takes a lot of time because you have to attach your credit card, all your billing details and number of things. So once you log in, this is the homepage you would get. It will ask you which service do you want to use. So you can type EC2 and from there you can directly click on this. EC2, and once you click on this, you will directly get the page which contains the EC2 part. Okay. Oh, Vijay, you are asking about the Jarvis. Okay. No, that's running a CPU. So that is not open for all. That's a paid service, if that was your question. And they have a pricing model. You can check it on their webpage. Okay. So there are a lot of local issues, like, and the best thing that I find in the cloud is it's not too costly, number one, and portability. I can, access the same code in whatever laptop, whatever, and wherever I am, because my entire code is always there on cloud, right? Portability is one big advantage you get, and then you can ramp up your CPUs to GPU at any point of time if you want some serious or heavy computing. So you are not dependent on a very costly laptop now. Okay, so you can run a Chromebook and actually make deep learning models. So the money that you save, okay, so Chromebook comes in 18,000, 20,000 here, very decent Chromebook. So you are saving 1 lakh easily, because the laptops with GPUs will be 1 lakh plus easily. Okay, the decent ones. So this money saved should be used in your cloud. Okay, cloud services. So that's the scalable thing which AWS is banking on. Fine. So I'll click on the instances here. And you have to log in as a root user. Okay. Make sure that you are logging as a root user. And instance state, nothing is running. Let me just. Okay. So now if I show you, because again, in the interest of time, how to create an instance and all that is very difficult. Okay, maybe we can discuss this in another follow-up session, how to create instance and configure it and all. Right now, I'll directly show you that this is the instance where I have already, deployed it, but that deployment part I'll slightly discuss. How did I do that? Okay, so once you start your instance. So did I start my instance? Sorry, I did not. So this instance is created. I have to just click here and actions. Okay. So from here, you can actually launch it directly. So this might take some time to launch. So it is launching. In the meantime, I'll go back to that instances tab. So it will take some time. Okay, for so it says stopped. Okay, instance state. Start the instance. Sorry, not that launch. Sorry, that is like creating a new instance. So click on the instance that you want to start. So yeah, this is not yet started. Now you can see the message pending. So earlier it was stopped and now it is pending. So let that start. Let that start. So in the meantime, we'll do some. Okay. So when you create an instance, it will ask you to create a PEM file, basically a key. Okay. So all that things. So I'm going to skip for now. Click on the instance. And from here, go to connect. But before that, it has to get started. So we'll check back whether it is still pending, because unless that is started, we cannot connect with it. So yeah, so that started. So I'll click on it once again, the instance ID. And okay, click on the connect. Okay, and then if you see, there is a SSH client. Okay, so from here, copy this code. So click on this. So instance ID is copied. So this code is copied. Okay. And now it says these 3-4 steps. Okay. So open a SSH client. So I have got putty with me. Okay. So I'll open that putty, and that is my SSH client. Locate your private key, and then it says run a few commands. So with that, so I'll just copy the bottom one because that is the full thing which I'll need. Okay, so I just copied this. I'm just opening my terminal. Okay, so let me just quickly share my screen. I just opened my terminal, PowerShell. And, okay, I have to browse to my downloads, and that is where I have my PEM file. Let me just show you. In the downloads, I have my PEM file. That starts with models. So let's call it as model underscore deployment. Let me search. So many files. Okay, so I have my PEM file here. Okay. So model deployment new. Okay, so this is the PEM file that we have to use. Okay, so I'll go back to my PowerShell, and let me paste that code. I have to make sure that the PEM file name is exactly same as that. Okay, so I'll go back, change this PEM file, model deployment new, right? .pem, press enter. Are you sure you want to connect? Yes. So what am I doing? I just connected to my remote EC2 instance. Is that clear? I just connected to my remote EC2 instance, which is running. Harendra, you are asking where do you get this PEM file? When you create your instance, you will get this option of saving the key pair, okay, as a PEM file. You will get that option. Save it in your local machine. Okay. So all that steps I had already mentioned in the description of this data. The 3 steps: how to create an instance, launch an instance, and then how to connect it. So connecting is what I'm already doing it in front of you. So I have already done this part. Till here, I hope it is fine. Okay. So once you have the PEM file, this is like a username password. So PEM file contains the username and password to your EC2 instance. Okay. Fine. Now what I am going to do is I'm going to do a git clone on this. So git clone, although it is there, but I'm still doing it. Okay. So do a git clone, and then you have to give the link for your GitHub repo. Okay. So let me just copy that link from the chat box. So I'm cloning that repo. Perfect. So that repo is cloned. Okay. So where did it get cloned? It is getting cloned in your EC2 instance. So all those files in your GitHub repo, all these files, where did that get stored? They got uploaded there. Okay. Uploaded. So that is done. Okay. So these are the dependencies. So now the next step is to install all this. Fine. Okay, let me just check. So let's do ls. Okay, within the model deployment. Okay, so this is the one which I just uploaded. Okay, so in that EC2 instance, I've got 2 folders. One is by this name, another is by this name. So you have to make sure that whatever Git hub link you have uploaded is really uploaded. So how do I do that? ls. This is just listing out all the folders in your instance. So I've got 2 folders. One is the model deployment, which just now got cloned. Earlier, it already had by this name, whatever. Fine. So I've got 2 models. Essentially, each of these folders contains one model. Okay. So which model you are going to run, that will be served finally. Where is it going to be served? I'll show you the link. Okay. So ready. So this is going to list the folder, and let me enter the model deployment. So I have entered the model deployment. Okay. I'm just increasing the font size. Let me do a ls and check whether all the files are there. Perfect. All the files are there. And then what we can do is, if you are launching this for the first time, then you should update your instance. Okay. Now that might take some time creating a virtual environment. Okay, let's do it. So I'll do sudo get update. So this is going to update all the packages available in your instance. Okay. Okay. apt install. Let me install Python 3 virtual environment. Okay. What am I missing? What am I missing? Let me check once again. APT get date. Is that no? Oh, sorry. Again, spelling mistake. Oh, correct. Thank you. some silly mistakes I'm doing. So please. So it's good that we have experienced people in the sessions who can do the debugging and help me out during the session. Thank you, guys. Thank you. Okay, so sometimes I get out of my mind and do some silly mistakes. So thank you. So what did I do? I just tried to get all the updated packages. And of course, I have to do the same thing. So I'll just copy it from the chat box. This will install Python. Okay. So Python 3 is already the newest version. Okay, fine. Now I will have to okay, no worry. So again, I'll have to install a virtual environment because Python is already there. It says, okay, it is already set to the newest version. So 3.10 is already there. I'll just create a virtual environment, okay? So this will be sudo apt get install Python 3 venv. venv. Let me see. So fine. Fine. So we have our virtual environment. Let me install pip on this. Okay. So for that, again, sudo apt install Python 3 pip. Why do I need pip? Pip will be needed to install other packages. Okay, so pip is also there, I guess. Let me check if I can directly run Python 3. So I'm just entering into my virtual environment. Sorry, creating a new virtual environment. And let's call it as model deployment. Okay. So this is like creating a new virtual environment here. And then let's get into it. Sorry. Source. Then we have the virtual environment name. So model underscore deployment. There will be a bin file within that. And let me activate that environment. Okay. So can you see here? Earlier it was base. And now I'm within the new virtual environment which I just now created. That is called as your model deployment model dev. Okay. So finally, let's install our dependencies using pip because we just now installed pip also. So pip install -r without, so that's like recursive, and there was a requirements.txt file. Okay, requirements.txt might take a couple of minutes to install all the dependencies. And just 1 or 2 more minutes. That's it. Okay.
No problem.
This is almost done. Okay, so all the necessary packages we have installed in our EC2 instance. Okay. Next, we have to run my app file. So what is the name of my app file? Let's go back and check. So it is app1.py, right? And please note one important file. This is called as a proc file. This is a proc file which mentions the app one. So why I'm talking about this is, see, the kind of framework that we have created is like this. Let me draw the framework because it's almost ready. We just have to launch it. So you have your model. This, let's say your model. On top of it, you have your Flask. So this is where you have your Flask, which is going to serve your model. Now, the kind of communication between your Flask server and your model is your Python code. Fine. This is your virtual environment where all the other dependencies to serve that model to the external means your web. Okay. So you guys are sitting from Nigeria and you want to access my model. Okay. So for that, you will need this Nginx ng unicorn. So workzerb also, if you had noticed, there's something called a workzerb. So all these things will create a sort of a protocol. Now, what is the name of this protocol? Okay. So this is your WSGI. WSGI. This is called as Web Server Gateway Interface. Web Server Gateway Interface. So this is a WSGI. So this EC2 instance will ping your Flask via WSGI. That is the protocol. So this outer red box, that's your EC2 instance. So your EC2 instance will ping your Flask model via WSGI protocol. That is the name of the protocol. And where are you sitting? You are sitting somewhere in Nigeria. Okay. Let me draw that also. So this is your client machine. This is a client machine, and this could be anywhere on this planet or even on Mars. Okay, so anyway, Elon Musk is preparing for that. How are you going to communicate to my EC2 instance? So this is my EC2 instance, right? That communication interface is HTTP. This is your HTTP. So please excuse my drawing and writing skills right now. I am just using my finger to write it here, but at least this is legible. This is, yeah, understandable. The very basic framework of what we have done. We created a Flask model. We created a EC2 instance. We post my entire GitHub code into the EC2 instance. Okay. We installed all the dependencies, and the only thing remaining is to start the app. The model has not yet started running, which is why if you try to access the EC2 instance, it will still say not found or internal server error, something like that, because my app is still not running. So that is the last point I have to do. Okay, but before I get to that app running, how are you accessing your EC2 instance from anywhere on this planet? Via this protocol HTTP or HTTPS. Okay, so that is the kind of framework or architecture we are running here. Perfect. So if your app file name, that Python file name, okay, please make sure, because this is one of the most common mistakes I've seen people doing, okay, unknowingly. So whatever be the file name here, whatever be the file name, put that exact same name without the py extension here. This is your app file name. That's it. That's the only change you have to make. Right? That's it. So that is the only file that I had not yet discussed. So can I go back to my EC2 instance? Okay, sorry, terminal. So finally, let me start this file. So Python 3 and app 1.5. Bingo. So your Flask application has already started running on the EC2 instance. So if we have not got any error message till here, that means we are good to go. Yeah, once again, I repeat, what did I do just now? My Flask application is running in the EC2 instance. The only question is how you guys are going to access this. Okay. So for that, I'll go back to my EC2 instances. Okay, I'll go back to my EC2 instance. Okay. And I'll click on this instance ID. Fine. And this second, let me check. Can you see there is a public IPv4 DNS? So this is the thing we are looking for. Okay, this is the thing we are looking for. Fine. So open this address. Okay. One small change you might need to do is delete the HTTPS. Delete that S. Access it via HTTP. Okay, that is one thing. And what else? Should have got P // Why you remove the port numbers of that? Change to equal. Okay. Fine. So this is running in the port 5000, it says. We'll try to access the port 5000 and see. This is the last attempt. Okay. So where is my EC2 instance? Go to the running instances, instance ID, and open the address. Okay, so HTTP and 5000. Oh my God. Oh, bingo. Okay. So patience pays off. Good. So whatever message we had typed, let me just copy paste our spam message. We were able to access that somewhere, right? What was that message? Let us see if that is also working. This is my EC2 instance. So I'll give a link for this and everyone can try this out, okay? So do not forget to add HTTP, okay? So please everyone have a look. So there is one change which I have done in the Git file, okay? So this Git file has to remove the, I'll just remove it here also so that this problem will not happen. So the only thing which I probably was missing is adding the host and not the port. I keep making a lot of changes. Anyway, so thank you for your time and being patient. We have been able to finally get this. So everyone, please, I have posted the link in the chat box. Okay, sorry, it was sent it to post. So I'm just reposting it in case anyone missed. So can someone please confirm if you are able to access this instance? And once you are done, do not forget to stop your instance also, right? Otherwise, Amazon will start billing you. And then one fine day, they'll come back and say, okay. So once you are done, go to your running instances and from the actions, select this and stop it from there. Sorry, instance state. Stop the instance. You don't reboot or terminate. You can also do a reboot, fine. If you terminate it, then you'll have to start from scratch. Okay. So then you would not see this. You'll have to create the instance, configure it, and a number of things. So everything will have to be repeated, right? So, okay, so we had some very hard learnings from here, right? Good. So the thing that I was missing out is probably that host 0.0.0 and port. I think because we had seen the uh, inbound rules, okay, all ports were open for HTTP. So if you go back and see, probably in networking somewhere I had opened that, right? So all ports were open. And when you run your Flask application, it directly gives you the port where to access. Okay, it gives you the port number where to access. So use this port number, and this is your public. This is your public IP. So this can be verified. So this can be verified. 172 dot something something, right? So can you see here 172.131? Sorry, 31.0.18. That's your IPv4 address. That's your IPv4 address, and this is the port. And in between, a lot of other things are there. So you don't have to really bother about all that. Just make sure that while opening or accessing this, you provide your port number properly. Okay. There is one question, so I'll take 1 or 2 questions before we end up. It's already more than 1.5 hours. So why not use SageMaker? SageMaker is billable from day one, from the very first second. Okay, so that is the biggest problem. In SageMaker, you'll have to create your entire model within SageMaker itself. SageMaker Studio has every other thing, so that's one good advantage. But here I am creating model in my own programming environment. I'm only using cloud for deployment. So what you are telling me is, or what you are suggesting is, why not use the entire cloud infra itself to create a model? You can very well do that. Okay, and in fact, there is a Python API available, which is what we call as Boto3. So you can use the Boto3 SageMaker API to actually create your model also. Okay, so just Boto3 SageMaker. You can dump your model in a S3 storage. Okay, so your model can be dumped in S3 storage, which can be accessed via your SageMaker Studio. So even that is possible. We have done that. Third thing I have done that is accessing these endpoints via a Lambda function. So that probably I might take in some other session. So you can actually invoke these endpoints via a Lambda function also. That is a serverless method. Okay, and the fourth thing that you can do is you can actually Dockerize your entire application, Flask application. You can Dockerize it, and you can upload your Docker container, host it in one of the S3 storage or your instance, basically. So whenever your instance starts, that Docker instance also starts. And so the biggest advantage of the Docker thing is all this port and all that thing gets sorted automatically. And you don't have to install any of the packages because the Docker container will by default have everything. So all the packages install Python and including your code. That Docker will have not only your code, but also all the dependencies and everything. You just have to dump your code into your EC2 instance, start your instance, and your application is there running. So that is another way. So these are the 3-4 ways you can actually get your model on the cloud. Okay. So one is what I have shown you, very lean and thin kind of thing. Okay, and almost free. If you have created your account, this EC2, as long as you're not, accessing GPU-based instances, it's a T2 micro kind of thing, Linux instance. This is all free, and this will be free for at least 1 year. So you can actually access this. So the compute time is not billed for you, billed to you for at least 1 year. So these are one of the big advantages of using this architecture or this infrastructure or this kind of method of deploying also, right? Second, as we said, you can use the SageMaker Studio altogether to create and directly deploy a model. And there is a Python 3 API available. This is your Boto3 Python API. where you can use SageMaker service. But again and again, I'm repeating, SageMaker is built from day one. It's not free. Okay. Third thing I talked about is you can actually invoke these API endpoints via Lambda functions. Okay. So that is the third way. And the fourth way is you can Dockerize your entire application and put it within your SageMaker, EC2 instance. So that is also possible. Okay. Okay. So enough done today. I think we have. Sorry, I close that instance page. So I think everyone has accessed that page, EC2 instance. So before closing the session, let me close that, stop that EC2 instance. Just that I do not want to be surprised at the end of the day by a bill, although it won't, but it's a good habit that the moment you are done, you should stop your EC2 instances. Okay. Let me check the Q&A section. So Harendra is asking, deployment can be done only through cloud? No, so we have seen both, right? We have deployed it on local machine. You have deployed it on cloud both. So, or you can create a virtual private cloud for your own organization. That's the thing, VPC. Another question. Sandeep is asking, what is the main purpose of using Postman? Postman is to quickly check your API endpoints. Simple. Okay, quickly check your API endpoints.
Thanks a lot, Prashant sir. On behalf of Analytics Vidya. Yes, sir.
I'm just unsharing my screen and then
okay, sir.
Stop the instance. So I'm stopping the instance. Okay. Done. Stopped. So I'm safe now.
Thanks a lot, sir. On behalf of Analytics Vidya, I would like to thank you for your time and delivering such a wonderful session.
Thank you.
Thank you. Our audience found it insightful, and hopefully we can conduct more such sessions in the future. We'll be back with another session of DataHour on 8th of February. The link is in the chat section. Till then, bye-bye and keep learning. Thank you all.
Thank you.